In this Algebra 1 video, we're talking about Chapter 3, Lesson 3, Rate of Change and Slope. And I'll already tell you this now, those are synonyms for each other, meaning they mean the same thing. Our objective is, as the student, I can use rate of change to solve problems, and I can find the slope of a line because I will keep track of what is changing and how much. When I say what's changing, I mean literally your input is changing, your output is changing, or your dependent variable, your independent variable. So that stuff we talked about last year in 7th grade, it's going to be the same thing. So if you need help, in that video I go a little bit more in depth explaining it. So if you need a refresher on some of that stuff, if it doesn't quite remember what it is, check out that video from 7th grade last year. Alright, so let's jump into some vocabulary. Rate of change. Rate of change is a ratio that describes, on average, it's usually for consistent, constant things. Anyways, how much one quantity changes with respect to a change in another quantity. And feel free to abbreviate some of these words if it helps. Now, what that means is this. We literally, if we said the change in y over the change in x, like divided by, ratio means a fraction, or being compared with division. So a change in y and the change in x, that's what that says. But you can use all those words that also mean y. You can say change in output, change in dependent variable, because y is your dependent variable. We don't know y until we figure out your independent variable, the one you get to choose, the one that is the input, or x. So remember all those words that mean the same. There should be a review of that. So you've seen something like this from last year that should look very familiar. Another way of thinking of rate of change, especially when we're talking about a graph specifically, like a graphed line, we're going to talk about slope. Slope is the slope of a non-vertical line is the ratio of the rise to the run. Meaning rise, meaning how far up or down does it go, and the run is always referring to how far to the right that it goes. And so you pick 2 points. So with a visual, if you chose, let's say, these 2 points on your line, you would look at how much it goes up, and you would look at, since this line clearly is going up, like that, and then you would look at how much it goes over. You could count visually by saying, you could say, okay, it goes up 2, it goes over 3, so that slope is going to be up 2 over 3, so 2 over 3, if you had something to count. In this example, we don't. Or you can actually calculate it. How far up it goes can be found by finding your change in y, or saying the second y value minus the first y value. That says y2 minus y1. That's a fancy way of saying the second one minus the first one. The second one being the one furthest to the right, the first one meaning the one furthest to the left. So look at those y values. And the dot, by that I mean by furthest to the left. Because this one's furthest to the left, we call that one x1, y1. And then we call this one x2, y2 because it's not furthest to the left. Technically, as a heads up, if you name these backwards, if you call this bottom one x2, y2, you won't get the wrong answer as long as you're careful with your negative signs. You'll still end up with the correct answer, but it gives you sometimes a double negative or gives you a sign that's slightly different, but if you follow the order of operations, it does still turn the same thing. Okay, and then find your horizontal change, or your run, as you can call it. That's by looking at your change in x's, by taking the second x value and subtracting out the first x value, and you'll have your change in x. Okay, so this was a reminder of what constant rate of change and slope was. Now we're going to do some examples. Oh, I lied. Got to talk about the special cases first. Alright, so we have 2 special cases for slope. A vertical line has an undefined slope. Because it has no run. It is literally just a straight drop. So there's no slope if it's a straight drop. So it has no slope as an undefined. Having 0 slope means it's horizontal, meaning it has lots of run, but it never rises, it never declines. So it is just going to be a consistent flat line. So that's a horizontal line. And the mnemonic device to help you remember that is a phrase called hoi vux. I came across this later in my teaching. I can't credit for the one who came up with it, but I came up with it somewhere. Don't remember well. Do not remember where, but I know that it works. So what it tells us is this: a horizontal line has a 0 slope. Okay, so that's what I wrote. Horizontal lines have a 0 slope, and its equation will be y equals a number. That's the format. So let's say y equals 4. That'll be a horizontal line. Or y equals -3. That'll be a horizontal line. And in fact, y equals 4, I think that's an example maybe even done in class in one of our prior assignments. Okay, so now do the opposite for the vertical lines. A vertical line has an undefined slope, and the equation will have the format of x equals a number. So vertical lines have an undefined slope, and the slope will have the equation will have the format of x equals a number. There won't be a y in the equation. It'll just be x equals a number. Just like in the vertical line, the horizontal line will have y equals a number as the equation of that linear line. So these are the special cases for slope and for lines. Now we're going to do some examples. Alright, so let's do this one first. Your job is literally to find the slope between these 2 points. That's your job. What is the slope between them? And so notice, there's no graph given in this example. Yes, you can take the time to draw yourself a graph and graph these out. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. You're welcome to actually graph these out, and it'll look something like that. That's a real sloppy version of it. And then you could just count, like look at your line, you can just count. But that can get very tedious, and not to mention that can also be very sometimes inaccurate if you're dealing with decimals, fractions, or what if they're really far away and it's not reasonable to count them. So the method that we're going to focus on is we're going to focus on using the slope formula. And the slope formula, if you haven't written it down already, make sure you get this down. You should have already had it. It's y2 minus y1 up top, and then x2 minus x1 on bottom, meaning change in y is on top, change in x is on bottom. That's what we're going to do. So I just went ahead and copied and pasted it. So yeah, so this is what we're going to do. So what we're going to do first is, if you want to be consistent, if you want to help avoid extra negatives, you can do what I'm about to do. You can make sure you understand which one of these is x1, y1, which one is x2, y2. And the answer is the one that, if you look at the x values, the one that is further to the left on the number line, that's going to be x1, y1. So 3 is further to the left than 4, therefore this is x1, y1. Meaning this, if you want to actually literally label it, this one will be x1, and then I'll make this one x2, and then this one will be y1, this one will be y2. Meaning that's just saying this is point 1, this is point 2, the 2 points we're dealing with. So if you do this, if you take that time, you can avoid any extra negatives. But even if I said it, even if you get it wrong, as long as you're consistent. Meaning we're about to do 8 minus 6 up top. And then we're going to have to do 4 minus 3 on bottom. If you had it backwards, you accidentally did 6 minus 8 on top, not the end of the world, as long as you do the bottom in the same order, 3 minus 4. But if you do different orders on top and bottom, then there's no excuse for that. You'll just have the wrong answer. So let's plug those in. Up top, we're going to have 8 minus 6, since we said y2 minus y1, so 8 minus 6 is on top. And on bottom, we're going to have 4 minus 3. So we just simply solve for on top and bottom. And on top, we get 8 minus 6 is 2. On bottom, 4 minus 3 is 1. Well, that's equals 2. So that tells us our slope is 2, meaning our slope will rise 2 and run 1, meaning it goes up 2 over 1. And if you remember that quick ugly sketch I did, it looked like it went up 2 over 1 was the general idea of what it did. So this is the slope of that line. You found it. You're done with this question. Okay, so give this one a shot. And as a reminder, I'll go ahead and copy and paste your formula for you again right next to it so you can see it. This is what we're going to use for this. We're going to solve for the change in y and the change in x. So hit pause and give this one a shot. Sorry, I got kind of cramped. I just want to move that out of the way. This step is optional, but it helps you stay organized. The one furthest to the left is going to be negative 6. Negative 6 is further to the left than negative 2. So because of that, this point is point 1, and this is point 2. So now if you plug them in that order, you can avoid any extra negatives. Alright, so let's get them plugged in. You know, put 2 minus 4 on top. Well, 2 minus 4 is negative 2. And on bottom, you have negative 2 minus negative 6. Remember, when you minus a negative, that becomes plus a positive. So that's really saying negative 2 plus 6. Well, negative 2 plus 6, that's positive 4. So we have positive 4 down here. So we have negative 2 over 4. Well, that simplifies. And that simplifies to negative 1 over 2. So that means our line will go negative. Since it's negative, our line will go down 1, and it'll go over 2. That's what that's saying. So our slope is negative 1 over 2. Now, I want to point out that even if you had written these backwards, you still could get the correct answer. Meaning, if you wrote the order. Let me show you what I mean. So, if you had accidentally written it in the wrong order, let's say you named them backwards, or let's say you just didn't, you forgot altogether. This is your other option of what order you could have subtracted them in. And if you had done this, you would have gotten up top, 4 minus 2 is positive 2, so it's different from what it was before. And on bottom, negative 6 minus negative 2, remember that means minus negative means plus, so it's really saying negative 6 plus 2, well that's negative 4. So you'd have 2 over negative 4, and that's still going to simplify to negative 1.5. Meaning, if the negative's in the bottom and the negative's in the top, it doesn't matter. If one of them is negative, the whole fraction has a negative value. So if you'd done it in this order, you would still end up with the exact same answer as long as you're careful with your negatives. So that was another example with slope. Okay, I'm now gonna let you try a couple examples. Actually, I lied. I want to do a slightly sideways question, and I'm gonna show you what I mean. All right, you try one more example, just to make sure you got it. All right, here's your example: 2, 1, 8, 9. Make sure you can get this. And I will point out, improper fractions are allowed for slope. Only for slope. We leave it as an improper fraction. That's your hint. All right, give this one a shot. If you want to take a moment to identify which one is which, now plug them in. Up top, 9 minus 1 is 8. On the bottom, 8 minus 2 is 6. You have 8 over 6. Well, that fraction simplifies to 4 over 3. And I said leave improper fractions as improper fractions. So that is your slope. Your slope is 4 over 3. And to help you interpret that, that means it goes up 4 over 3 is what that means. So you found your slope. Now let's do a slightly backwards question. Alright, so in examples like this, you're given 2 points, one of your coordinates is missing in one of your ordered pairs, but you are given the slope. And the question is going to say something along the lines of, find the value of r so the line that passes through each pair of these points has the given slope. Meaning, what is the value of r so that when you do find the slope, it'll equal 3 over 4. That's what they're asking. So that's what we're going to do, is we're going to plug in what we know using the slope formula, and we're going to solve for the piece that we don't know. In this example, we know which one is further to the left. It's going to be the -1, so this is going to be the x1, y1. But technically, sometimes you might be missing on the x's. You might not be able to tell. So honestly, it doesn't matter if you accidentally put those in the wrong spot. So essentially, we're going to plug in what we have into the slope formula. So if you name them this way, we're looking for the y2 value is what we're looking for. So if you plug them in, you'll get something like this. And we already know the answer to this question. The answer to this question is going to be 3 over 4 because that was given from over there. So our job is to simply solve and see what's going on with some of these values to help us get these. And you'll notice, if you were to actually solve this question, let's say we knew what the bottom was, you notice the bottom doesn't equal 4. The bottom's going to equal 8 because that's 7 plus 1. So the bottom's going to equal 8, so that means we must have simplified our fraction. So the top must be 8, but the bottom is 8. So now for the top, we originally said it's going to become 3 over 4. And you notice we simplified the 8 to a 4, we cut it in half. So that means we must also cut something else in half up top to make it a 3. So that means the top must be a 6. So sometimes the slope in these questions may have been simplified. So really that means we had 6 over 8. So your question is, what plus, because it says minus and negative, what plus 3 will give you 6? And that answer is going to be 3. 3 plus 3 would give you 6. Meaning the value of, as if there was a 3 right here, this would work out. Because because remember, minus and negative means plus, it's going to give you positive 6. So you have 6 over 8 and it's divided by 3 or 4. So you found your blank by doing that. Now, if you wanted to go further, you could just say this. You could say r plus 3 equals 6, solve for r, meaning minus 3, so you have 3 equals 3. Since it was cancel, I said 3, I totally meant r. So r equals 3. So you could actually take the time to solve it, but if I don't mind at that point if you just kind of fill in the blank. So this is what I mean. The value of r is going to be 3. That's what we were able to find. And by plugging in what we knew into the slope formula, and in this case, we even added that step in between because we saw it had been simplified because it went from 7 minus -1 to 4. So that's how we knew it was simplified. And you go through and you solve for what you don't know. So it turns out the value that would make it have a slope of 3 over 4 is the y-coordinate value of 3. That's what r ends up equaling. Alright guys, keep calm, show your work. The slope formula is your friend. When in doubt, you can always graph and count on the graph, but I wanted you to also have a way that always works regardless of what you're given. Alright, take calm, show your work. Stay calm, show your work, and it'll be just fine. Take care.